In 1915, Albert Einstein published his theory of general relativity, fundamentally altering our understanding of space and time. What he couldn't have anticipated was how his equations would later provide a theoretical framework for one of humanity's most persistent questions. Could the ancient astronauts described in mythologies worldwide actually be time travelers from our own future? The mathematics of relativity reveal that time itself is malleable, stretched, and compressed by gravity and velocity in ways that challenge our everyday experience. Near massive objects like black holes, time slows dramatically relative to distant observers. At 99% the speed of light, a journey that feels like months to travelers would span decades for those left behind. These aren't science fiction concepts. They're measurable, observable phenomena that spacecraft engineers must account for in satellite navigation systems we use daily. Consider this scenario. An advanced civilization from Earth's future discovers archaeological evidence of their own intervention in ancient history. They realize that their ancestors' technological development depended on knowledge mysteriously appearing in ancient texts, knowledge they now possess. To close this temporal loop, they must journey backward in time to plant the very information that enabled their own existence. The conventional interpretation of ancient astronaut theories assumes visitors from distant star systems. But what if the vast distances involved aren't spatial, but temporal? What if the gods who descended from the heavens in Sumerian texts, the sky people of Native American traditions, and the divine beings described across cultures weren't extraterrestrial at all, but rather terrestrial, separated from ancient civilizations not by light years, but by centuries or millennia? General relativity provides several mechanisms through which such temporal displacement could theoretically occur. The most straightforward involves what physicists call gravitational time dilation. In regions of intense gravitational fields, time passes more slowly relative to areas of weaker gravity. This effect becomes pronounced near massive objects, neutron stars, black holes, or even artificially created gravitational anomalies. Dr. Kip Thorne's research at Caltech demonstrated that traversable wormholes, while requiring exotic matter with negative energy density, remain consistent with the known laws of physics. These theoretical structures could connect different points in space-time, potentially allowing travel not just across vast distances, but across vast epochs. More intriguingly, the Alcubierre drive concept, proposed by physicist Miguel Alcubierre in 1994, describes how space itself could be warped to achieve effective faster-than-light travel, a process that inherently involves temporal displacement due to the intimate connection between space and time. But perhaps the most accessible method for temporal displacement involves what's known as the twin paradox effect, scaled to cosmic proportions. A civilization possessing technology capable of accelerating spacecraft to near-light speeds could send expeditions on circular journeys through space. Due to time dilation effects, crew members would experience months or years while centuries pass on their home world. By carefully calculating trajectories and acceleration profiles, they could emerge at precisely predetermined points in their planet's past. The energy requirements for such endeavors appear staggering by current standards, but they're not physically impossible. A Dyson sphere, a hypothetical structure capturing a star's entire energy output, could theoretically provide sufficient power for large-scale temporal displacement projects. Advanced civilizations might harness the rotational energy of black holes through the Penrose process, extracting energy from the ergosphere surrounding these cosmic giants. Archaeological evidence that might support temporal intervention theories requires careful re-examination through this lens. The Antikythera mechanism, discovered in a Roman-era shipwreck, demonstrates computational sophistication that wasn't predicted to exist until over a millennium later. Rather than assuming ancient Greeks independently developed complex gear mechanisms, we might consider whether this represents knowledge transferred from a more technologically advanced period. Similarly, the precision of megalithic constructions worldwide, from Puma Punku in Bolivia to the Giza Pyramid Complex in Egypt, suggests engineering knowledge that challenges conventional timelines of technological development. The massive stone blocks at Puma Punku, some weighing over 130 tons, are cut with tolerances measured in millimeters and feature complex interlocking designs that would challenge modern construction techniques. Ancient texts provide another avenue for investigation. The Mahabharata, an ancient Sanskrit epic, describes weapons and vehicles that bear striking resemblances to modern military technology. The Vimanas mentioned in these texts aren't simply flying machines. They're described with technical specifications including propulsion systems, navigation equipment, and defensive capabilities. While traditionally interpreted as mythological, these descriptions take on new significance when considered as potential documentation of advanced technology introduced by temporal visitors. The Book of Ezekiel's famous vision includes detailed descriptions of what modern readers might interpret as spacecraft or advanced machinery. The precise geometric descriptions, wheels within wheels, creatures with multiple faces, and movements that suggest advanced propulsion, read less like religious allegory and more like technical documentation when examined through the lens of someone attempting to describe unfamiliar technology using available vocabulary. Sumerian creation myths speak of the Anunnaki, beings who came from the sky and possessed knowledge of agriculture, metallurgy, and astronomy. These accounts describe specific technological interventions: the introduction of farming techniques, the development of written language, and the establishment of mathematical systems. If these represent actual historical events rather than purely mythological narratives, temporal displacement provides a more parsimonious explanation than interstellar travel. The temporal intervention hypothesis also addresses several puzzles in the archaeological record. Why do similar construction techniques and artistic motifs appear simultaneously in geographically isolated cultures? Why do certain technological advances seem to emerge suddenly without clear developmental pathways? Why do ancient astronomical texts demonstrate knowledge of celestial mechanics that wouldn't be rediscovered until telescopic observation became possible? Consider the Dogon people of Mali, whose traditional cosmology includes detailed knowledge of Sirius B, a white dwarf star invisible to naked eye observation and not detected by Western astronomy until 1862. Their oral traditions describe its 50-year orbital period and its relationship to the brighter Sirius A with remarkable accuracy. Rather than invoking extraterrestrial contact, temporal displacement suggests a more direct explanation: future human astronomers sharing observational data with past cultures. The phenomenon of cultural diffusion, the spread of technologies and ideas across ancient civilizations, takes on new significance when viewed through the temporal intervention framework. The sudden appearance of metallurgy, agriculture, and written language across multiple cultures within relatively short time periods might represent coordinated technological transfers rather than independent innovation. Modern physics suggests that closed time-like curves, paths through space-time that return to their starting point in time, are theoretically possible under certain conditions. Kurt Gödel demonstrated in 1949 that solutions to Einstein's field equations permit such curves in rotating universes. While our universe doesn't appear to rotate in the manner Gödel described, his work established that temporal loops are consistent with general relativity under specific circumstances. The grandfather paradox, often cited as an argument against time travel, assumes that the past can be changed from its observed state. But quantum mechanics suggests an alternative interpretation. The many worlds theory implies that temporal interventions might create parallel timelines rather than altering existing history. In this framework, time travelers wouldn't change their own past, but would create new temporal branches where their interventions become part of the historical record. Recent research in quantum gravity suggests that spacetime itself might be quantized at the Planck scale, distances of approximately 10 to the power of -35 meters. This quantum foam structure could provide mechanisms for temporal displacement that don't require the exotic matter needed for classical wormhole solutions. Virtual particles continuously appearing and disappearing in vacuum space might, under specific conditions, create microscopic spacetime tunnels that could be artificially amplified. The energy scales involved in cosmic-level time travel suggest that only civilizations capable of manipulating fundamental forces could attempt such projects. But Earth's technological development is accelerating exponentially. What seems impossible today might be routine engineering for our descendants centuries or millennia hence. If they develop temporal displacement capabilities, the question becomes not whether they would intervene in their past, but how extensively they already have. Archaeological anomalies worldwide might represent the signatures of such interventions. The precision-carved stone spheres of Costa Rica, ranging from centimeters to over 2 meters in diameter and geometrically perfect to within millimeters, demonstrate manufacturing capabilities that challenge conventional understanding of pre-Columbian technology. The massive underground chambers at Derinkuyu in Turkey, carved from solid rock and capable of housing thousands of people, suggest engineering projects of unprecedented scope for their supposed time period. Genetic studies of human evolution reveal several unexplained accelerations in brain development and cognitive capability. The rapid expansion of human cranial capacity over the past 2 million years, particularly the dramatic increases that occurred roughly 200,000 to 50,000 years ago, wasn't predicted by evolutionary models based on environmental pressures alone. These sudden jumps in cognitive capacity might represent genetic interventions by temporal visitors seeking to accelerate their ancestors' technological development. The timing of these interventions would be crucial. Too early, and human societies wouldn't possess the cultural frameworks necessary to preserve and transmit advanced knowledge. Too late, and the technological foundation necessary for future time travel development might never emerge. The archaeological record suggests that major technological transfers occurred during specific periods when human societies had developed sufficient complexity to benefit from advanced knowledge while retaining the social structures necessary to preserve it across generations. Language itself provides another avenue for investigation. The sudden appearance of complex grammatical structures, abstract mathematical concepts, and sophisticated astronomical terminology in ancient texts suggests intellectual capabilities that developed rapidly relative to archaeological timelines. The Sumerian-based 60 mathematical system, still used for measuring time and angles, demonstrates numerical sophistication that enabled precise astronomical calculations. Modern attempts to decode ancient mathematical and astronomical knowledge reveal consistent patterns suggesting systematic knowledge transfer rather than gradual discovery. The Mayan long count calendar system, with its precise tracking of astronomical cycles over thousands of years, requires observational data spanning periods far longer than the civilization's apparent existence. This suggests either impossibly patient multi-generational observation projects or access to pre-calculated astronomical data from more advanced sources. The materials science evident in ancient constructions also challenges conventional technological timelines. The Iron Pillar of Delhi, standing for over 1,600 years without significant corrosion, demonstrates metallurgical knowledge that modern science has only recently begun to understand. The composition and manufacturing techniques required to create such corrosion-resistant iron alloys suggest knowledge of chemical processes not rediscovered until the industrial age. As we examine these anomalies through the lens of temporal displacement theory, patterns emerge that are difficult to explain through conventional archaeological interpretation. The consistent themes across cultures, knowledge-bearing beings descending from the sky, sudden technological advances, precise astronomical knowledge appearing without apparent developmental history, suggest systematic intervention rather than coincidental independent development. The implications extend beyond historical curiosity. If our future descendants are already intervening in our past, what does this mean for our understanding of free will, technological development, and human destiny? Are we following a predetermined path shaped by our own future actions, or do we retain agency in determining our species' trajectory? These questions transcend archaeology and physics, touching on fundamental questions of causality and temporal ethics that we've only begun to explore. Black holes represent the most extreme gravitational environments in the known universe, where the fabric of space-time curves so dramatically that not even light can escape once it crosses the event horizon. But within these cosmic monsters lies perhaps the most powerful mechanism for temporal manipulation available to sufficiently advanced civilizations, a phenomenon that might explain how beings from Earth's future could journey backward to influence ancient human development. The physics of black holes reveal temporal effects so profound that they challenge our intuitive understanding of causality itself. As matter approaches the event horizon of a black hole, gravitational time dilation becomes extreme. An observer falling toward a black hole would experience time normally from their perspective, but to distant observers, they would appear to slow down dramatically, eventually seeming to freeze at the horizon boundary. This isn't an optical illusion. Time itself runs differently in these intense gravitational fields. More intriguingly, rotating black holes, known as Kerr black holes, create a region called the ergosphere where spacetime itself is dragged around the black hole's rotation. Within this zone, nothing can remain stationary relative to distant observers. Everything must participate in the black hole's rotation. But the ergosphere also presents opportunities for energy extraction through the Penrose process, where objects can emerge with more energy than they entered with, powered by the black hole's rotational energy. For advanced civilizations, black holes might serve as both power sources and temporal manipulation devices. The extreme gravitational gradients near black holes create natural time dilation effects that could be harnessed for controlled temporal displacement. A spacecraft following carefully calculated trajectories around a black hole could experience months of subjective time while years or decades pass in the external universe. By varying orbital parameters, distance from the event horizon, orbital velocity, duration of stay, temporal displacement could be precisely controlled. The mathematics become particularly interesting when considering close approaches to the photon sphere, the unstable circular orbit at 1.5 times the Schwarzschild radius where photons can orbit the black hole indefinitely. Objects in this region experience maximum time dilation effects while still maintaining the possibility of escape. A spacecraft could theoretically orbit within the photon sphere for extended periods, experiencing massive time dilation, then escape to emerge in their past relative to distant observers. But black holes offer more exotic possibilities for temporal manipulation through their internal structure. According to general relativity, the interior of a rotating black hole contains closed time-like curves, paths through spacetime that loop back to earlier moments in time. While reaching these regions would normally require crossing the event horizon and becoming trapped, recent theoretical work suggests that under specific conditions involving charged or rotating black holes, stable wormhole-like structures might form. The Reissner-Nordström metric, describing charged black holes, predicts the existence of multiple event horizons and potentially traversable connections to other regions of spacetime. Similarly, the Kerr metric for rotating black holes includes mathematical solutions that permit time travel under certain circumstances. While these solutions require exotic conditions, negative energy densities, precisely controlled angular momentum, or other physically challenging requirements, they remain consistent with known physics. Recent developments in string theory and quantum gravity suggest that black holes might be even more complex than general relativity predicts. The holographic principle implies that all information falling into a black hole is encoded on its two-dimensional surface, creating what physicists call the black hole information paradox. If information is truly preserved in this holographic encoding, advanced civilizations might develop techniques for extracting and manipulating this information, potentially accessing data from objects that fell into the black hole at earlier times. The concept of black hole complementarity suggests that quantum effects near the event horizon might create multiple, equally valid descriptions of reality. From the perspective of an outside observer, objects falling into a black hole appear to be encoded on the horizon surface. From the perspective of the falling object, they pass through the horizon and continue toward the singularity. Advanced civilizations capable of manipulating quantum information might exploit this complementarity to create controlled temporal displacement effects. Archaeological evidence suggests that ancient civilizations possessed knowledge of astronomical phenomena that wouldn't be expected given their apparent technological limitations. The Antikythera mechanism's ability to predict eclipse cycles, planetary positions, and other celestial events demonstrates computational capabilities that require detailed understanding of complex orbital mechanics. If this knowledge came from temporal visitors using black hole-based time travel, it would explain both the advanced computational requirements and the precision of the astronomical data. Ancient texts from various cultures describe cosmic events and astronomical phenomena with remarkable accuracy. The Mayan calendar system tracked Venus cycles with precision that rivals modern astronomical observations. The Babylonians calculated planetary positions using mathematical techniques that wouldn't be rediscovered until the development of modern astronomy. These achievements suggest access to observational data spanning periods far longer than individual human lifespans or even civilization durations. The construction of monuments aligned with specific astronomical events, such as the pyramids of Giza's correlation with Orion's belt or Stonehenge's alignment with solstices and lunar cycles, requires not just observational astronomy but predictive modeling of celestial mechanics. These alignments remain accurate across millennia, suggesting that their builders possessed knowledge of precession cycles, orbital variations, and other long-term astronomical phenomena. Ancient creation myths from Mesopotamia, Egypt, and other civilizations describe cosmic cycles of destruction and renewal that bear striking similarities to modern understanding of stellar evolution and galactic dynamics. The concept of cyclical time, where cosmic events repeat in vast cycles, appears in cultures worldwide. These narratives might represent cultural memories of actual astronomical observations provided by temporal visitors with access to long-term cosmic data. The energy requirements for black hole-based temporal manipulation are enormous but not physically impossible. A civilization capable of constructing Dyson spheres or other megastructures could potentially harness stellar energy output for large-scale spacetime manipulation projects. The concept of a Shkadov thruster, using stellar engineering to convert a star into a directional energy source, could provide the power necessary for controlled black hole manipulation. More speculatively, advanced civilizations might create artificial black holes for temporal displacement purposes. The concept of primordial black holes, microscopic black holes formed in the early universe, suggests that black holes can exist at various scales. While creating artificial black holes would require enormous energy densities, civilizations with access to exotic matter or vacuum energy manipulation might develop techniques for controlled black hole creation and manipulation. The quantum mechanics of black holes introduces additional possibilities for temporal manipulation. Hawking radiation, the quantum mechanical emission of particles from black hole event horizons, creates a connection between the black hole's interior and exterior. Stephen Hawking's original calculations suggested that this radiation is thermal and random, but subsequent work by physicists like Leonard Susskind and others indicates that the radiation might encode information about matter that previously fell into the black hole. If Hawking radiation truly encodes information about the black hole's contents, advanced civilizations might develop techniques for decoding this information to access data from earlier times. The process would essentially involve reading the quantum mechanical memory of spacetime itself, extracting historical information encoded in the structure of space and time around massive objects. The concept of black hole mining, extracting energy and information from black holes through controlled manipulation of their quantum properties, represents a theoretical technology that could power civilization-scale temporal displacement projects. By carefully managing the input and output of matter and energy around black holes, advanced civilizations might create controlled temporal environments where past and future exist in controllable relationship. Ancient accounts of divine beings or advanced visitors often describe them as emerging from or disappearing into regions associated with darkness or void, descriptions that take on new significance when considered as potential documentation of black hole-based transportation. The Egyptian concept of the Duat, described as a dark realm through which the sun god Ra travels during the night, includes geometric descriptions and navigation challenges that might represent ancient attempts to describe space-time curvature and gravitational effects. Similarly, various mythological traditions describe portals or gateways that connect different realms or time periods. The Norse concept of the world tree Yggdrasil, with its connections between different worlds, might represent cultural memory of wormhole-like structures connecting different regions of spacetime. The detailed descriptions of travel between these realms often include references to altered time flow, where brief journeys in one realm correspond to extended periods in another. The thermodynamics of black holes provides another avenue for understanding potential temporal manipulation techniques. Black holes have temperature inversely proportional to their mass. Smaller black holes are hotter and evaporate faster through Hawking radiation. By controlling the mass and energy flow around black holes, advanced civilizations might create controlled temporal environments where the rate of time passage can be precisely managed. The concept of black hole information processing suggests that these objects might function as natural computers, processing information through the quantum mechanical interactions occurring near their event horizons. If consciousness or information patterns can be encoded in quantum states, black holes might serve as storage and processing systems for temporal displacement of information rather than just matter and energy. Recent theoretical work on the black hole firewall paradox, the question of what happens to information falling into black holes, suggests that the interior of black holes might be more complex than originally thought. Some solutions to the paradox involve multiple, simultaneous realities where information exists in superposition states until observed. Advanced civilizations might exploit these quantum superposition effects to create controlled temporal displacement systems. The concept of black hole complementarity, where the same physical events can be described differently depending on the observer's reference frame, might provide mechanisms for temporal manipulation that don't violate causality from any single perspective. A civilization capable of switching between reference frames might effectively navigate between different temporal states while maintaining consistency within each frame of reference. Archaeological evidence of precision stone cutting and manipulation suggests technologies capable of controlling matter at the molecular or atomic level. The perfectly fitted stone blocks at Sacsayhuaman in Peru, the precise drilling evident in ancient Egyptian artifacts, and the complex geometric patterns found in megalithic constructions worldwide all suggest manufacturing techniques that require detailed understanding of materials science and precision engineering. If these technologies were provided by temporal visitors using black hole-based time travel, the precision and scale of these constructions make more sense. Civilizations with access to black hole energy sources would possess the power necessary for large-scale matter manipulation and precision manufacturing. The sudden appearance of these capabilities in the archaeological record, without clear developmental pathways, suggests technological transfer rather than gradual innovation. The alignment of ancient structures with astronomical events often involves not just current sky configurations, but predictions of future astronomical positions. The builders of these monuments somehow knew how celestial objects would move over thousands of years, accounting for precession, orbital variations, and other long-term changes. This suggests access to computational models or observational data spanning periods far longer than individual civilizations typically maintain detailed records. As we examine these ancient achievements through the lens of black hole physics and temporal manipulation, patterns emerge that suggest systematic intervention by technologically advanced beings. The combination of precise astronomical knowledge, advanced engineering capabilities, and sophisticated mathematical understanding appearing simultaneously across different cultures points toward coordinated knowledge transfer rather than independent development. The question becomes not whether such intervention occurred, but how extensively it shaped human civilization's development. The most compelling evidence for temporal intervention in human history lies not in monumental architecture or advanced metallurgy, but in the knowledge systems that appear suddenly in ancient texts without clear developmental histories. These anachronistic insights, sophisticated understanding of mathematics, astronomy, medicine, and physics appearing in civilizations that supposedly lacked the observational tools or experimental methods to develop such knowledge independently, present patterns that challenge conventional models of human intellectual development. The Sumerian mathematical system, appearing fully formed in the earliest known written records, demonstrates numerical sophistication that enabled complex calculations involving astronomy, engineering, and commerce. The base 60 system they developed remains embedded in our modern measurement of time and angles, suggesting a mathematical framework so elegantly designed that it has persisted across millennia. But the Sumerians didn't just use mathematics. They understood abstract mathematical principles that wouldn't be formally rediscovered until much later in human history. Consider the Pythagorean theorem, typically attributed to the Greek mathematician Pythagoras in the 6th century BCE. Yet Babylonian tablets from over 1,000 years earlier demonstrate clear understanding of the relationship between the sides of right triangles, including calculations involving what we now call Pythagorean triples. The Plimpton 322 tablet, dating to approximately 1800 BCE, contains a sophisticated table of these mathematical relationships that suggests systematic study of geometric principles. More intriguingly, ancient mathematical texts often contain knowledge that appears to emerge without the gradual developmental process typical of human intellectual discovery. The Sulba Sutras of ancient India, dating to approximately 800 BCE, contain geometric principles and calculations that demonstrate understanding of advanced mathematical concepts, including approximations of irrational numbers and geometric constructions that require sophisticated theoretical frameworks. The precision of these ancient mathematical systems becomes even more remarkable when we consider their applications in astronomy. The Antikythera mechanism, often called the world's first analog computer, demonstrates computational capabilities that required not just mechanical engineering expertise, but deep understanding of complex astronomical relationships. The device accurately predicted eclipse cycles, planetary positions, and other celestial events using gear ratios calculated with precision that rivals modern engineering. The Mayan long count calendar system represents perhaps the most sophisticated temporal calculation system developed by any ancient civilization. The system tracks multiple interlocking cycles: solar years, lunar months, Venus cycles, and longer astronomical periods, with accuracy that requires observational data spanning thousands of years. The Maya calculated Venus's synodic period as 584 days, compared to the modern value of 583.92 days, achieving precision that suggests systematic astronomical observation over extended periods. But how could civilizations develop such precise astronomical knowledge without the observational tools that modern astronomy requires? The answer might lie in the concept of temporal data transfer, information about celestial mechanics provided by future civilizations with access to comprehensive astronomical databases. This would explain both the precision of ancient astronomical calculations and their sudden appearance without clear developmental pathways. Ancient medical knowledge presents similar patterns of sophisticated understanding appearing without expected developmental histories. The Edwin Smith Papyrus, dating to approximately 1600 BCE, contains surgical procedures and anatomical knowledge that demonstrates understanding of human physiology that wouldn't be systematically rediscovered until the development of modern medicine. The papyrus describes surgical techniques for treating head injuries, spinal trauma, and other complex medical conditions with precision that suggests systematic anatomical study. Traditional Chinese medicine, with its detailed understanding of acupuncture points, herbal pharmacology, and physiological principles, represents another example of sophisticated medical knowledge appearing early in human history. The Huangdi Neijing, traditionally attributed to the Yellow Emperor around 2500 BCE, contains detailed descriptions of human physiology, circulation, and therapeutic techniques that demonstrate systematic understanding of human biology. The concept of temporal paradoxes becomes central to understanding how future civilizations might intervene in their own past without creating logical contradictions. The grandfather paradox, the classic thought experiment where a time traveler prevents their own birth, assumes that the past can be changed from its observed state. But quantum mechanics suggests alternative interpretations that resolve these apparent contradictions. The many worlds interpretation of quantum mechanics, developed by Hugh Everett III in 1957, suggests that every quantum measurement creates parallel universes where each possible outcome occurs. In this framework, time travelers wouldn't change their own timeline but would create new parallel timelines where their interventions become part of the historical record. This resolves the grandfather paradox by suggesting that temporal interventions create new branches of reality rather than altering existing ones. The concept of the Novikov self-consistency principle, proposed by physicist Igor Novikov, suggests that the universe's structure inherently prevents paradoxes from occurring. In this interpretation, any attempt to create a temporal paradox would be prevented by the laws of physics themselves. Time travelers could only perform actions that were already part of the historical record, creating closed causal loops where future events enable past events that make future events possible. This principle might explain the patterns of knowledge transfer evident in ancient texts. If future civilizations develop time travel capabilities, they would discover that their own technological development depended on knowledge that mysteriously appeared in ancient texts. To maintain causal consistency, they would be required to journey backward in time to provide the very knowledge that enabled their own existence, creating a stable temporal loop where effect and cause are indistinguishable. The archaeological record provides evidence that might support such self-consistent temporal loops. The sudden appearance of complex technologies, sophisticated mathematical systems, and advanced astronomical knowledge in ancient civilizations worldwide suggests coordinated knowledge transfer rather than independent development. The timing of these appearances correlates with periods when human societies had developed sufficient complexity to preserve and transmit advanced knowledge across generations. Language itself provides another avenue for investigating temporal intervention. The Indo-European language family, from which most European and many Asian languages derive, appears to have emerged and spread rapidly across vast geographical regions. Traditional linguistic models suggest gradual language evolution and geographic diffusion, but the archaeological evidence indicates much more rapid and systematic language spread than these models predict. The sophisticated grammatical structures and abstract vocabulary evident in ancient texts suggest intellectual capabilities that developed rapidly relative to archaeological timelines. The appearance of complex philosophical concepts, advanced mathematical terminology, and sophisticated astronomical vocabulary in early written records indicates cognitive and cultural sophistication that challenges conventional models of human intellectual development. Ancient texts often contain knowledge that appears to require experimental verification or systematic observation to develop. The Charaka Samhita, an ancient Indian medical text, contains detailed descriptions of human anatomy, physiology, and therapeutic techniques that suggest systematic experimental investigation. The precision of these descriptions indicates methodical study that would require controlled experimental conditions and systematic data collection. Similarly, ancient metallurgical texts contain knowledge of chemical processes, alloy compositions, and manufacturing techniques that typically require extensive experimentation to develop. The production of Damascus steel, with its distinctive patterns and superior mechanical properties, involved metallurgical knowledge that modern science has only recently begun to understand. The techniques for creating these advanced alloys appear in ancient texts without clear developmental histories. The concept of genetic intervention provides another framework for understanding how future civilizations might influence their own past. Recent advances in genetics and evolutionary biology reveal that human evolution included several unexplained accelerations in brain development and cognitive capability. The rapid expansion of human cranial capacity and the sudden appearance of sophisticated symbolic thinking might represent genetic modifications introduced by temporal visitors. If future humans developed advanced genetic engineering capabilities, they might recognize that their own cognitive abilities depended on genetic modifications that occurred in their ancestral past. To maintain causal consistency, they would need to journey backward in time to introduce the very genetic changes that enabled their own advanced capabilities. This would create a self-consistent temporal loop where advanced humans ensure their own evolutionary development. The timing of major cognitive advances in human evolution correlates with the appearance of sophisticated cultural achievements. Cave paintings, tool making, symbolic communication, and eventually written language and mathematical systems. These developments suggest rapid increases in cognitive capability that enabled the preservation and transmission of complex knowledge across generations. Ancient accounts of divine intervention in human affairs often describe beings who appear suddenly, provide knowledge or technologies, and then disappear. These narratives appear across cultures worldwide with remarkable consistency. Sky gods who bring knowledge of agriculture, metallurgy, writing, and mathematics before departing to their celestial realms. While traditionally interpreted as mythology, these accounts take on new significance when considered as potential documentation of temporal intervention. The consistency of these accounts across geographically isolated cultures suggests either common historical experiences or coordinated knowledge transfer. The specific types of knowledge attributed to these divine visitors, practical technologies, mathematical systems, astronomical knowledge, and medical techniques, correspond precisely to the types of information that would be most valuable for accelerating human technological development. Modern attempts to replicate ancient technologies often reveal that the knowledge required exceeds what conventional archaeological timelines suggest should have been available. The creation of Damascus steel, the construction of precision megalithic structures, and the development of complex astronomical calculation systems all require knowledge that appears to have been acquired more rapidly than independent discovery and development would predict. The concept of temporal ecology, the idea that time travelers must carefully manage their interventions to avoid disrupting the causal chains that enable their own existence, provides a framework for understanding the patterns evident in ancient knowledge systems. Major technological transfers appear to occur at carefully chosen moments when human societies possess sufficient sophistication to benefit from advanced knowledge, while maintaining the cultural stability necessary to preserve it across generations. The archaeological record suggests that these interventions follow consistent patterns. Knowledge appears suddenly in written form, often accompanied by claims of divine or supernatural origin. The information is typically practical, mathematical systems, engineering techniques, agricultural methods, or medical procedures that provide immediate benefits while establishing foundations for future technological development. The knowledge is preserved through religious or cultural institutions that maintain its accuracy across generations. Ancient libraries and knowledge preservation systems represent another aspect of potential temporal intervention. The Library of Alexandria, the House of Wisdom in Baghdad, and similar institutions worldwide appear to have possessed knowledge collections that exceeded what local civilizations could have accumulated through independent research. These libraries often contain texts that demonstrated understanding of scientific principles that wouldn't be rediscovered until much later periods. The destruction of these knowledge repositories, through wars, natural disasters, or cultural changes, follows patterns that might reflect temporal intervention management. If future civilizations needed to control the rate of technological development to maintain causal consistency, they might orchestrate the loss of certain knowledge at specific historical moments. The burning of the Library of Alexandria, the destruction of Mayan codices, and similar losses of ancient knowledge might represent controlled information management rather than random historical accidents. The concept of technological lock-in, where certain technological pathways become established and difficult to change, provides another framework for understanding temporal intervention strategies. By introducing specific mathematical systems, engineering techniques, or scientific principles at crucial moments in human development, temporal visitors could guide technological evolution along pathways that ensure the eventual development of time travel capabilities. The base 60 mathematical system introduced by the Sumerians provides an example of such technological lock-in. This system's mathematical properties make it particularly suitable for astronomical calculations and engineering applications. Its adoption by early civilizations established mathematical frameworks that facilitated the development of precise astronomical observation and complex engineering projects, capabilities essential for eventual space travel and temporal manipulation technologies. Similarly, the development of written language systems appears to follow patterns that optimize information preservation and transmission across generations. The sudden appearance of sophisticated writing systems in multiple cultures, each optimized for preserving complex technical and mathematical information, suggests systematic design rather than gradual evolution. These writing systems enabled the preservation of advanced knowledge across the cultural discontinuities that typically disrupt oral traditions. The concept of cognitive bootstrapping, where advanced knowledge enables the development of cognitive frameworks necessary to understand even more advanced concepts, might explain the rapid acceleration of human intellectual development following the introduction of writing, mathematics, and systematic observation techniques. Each technological advance creates cognitive tools that enable the comprehension of more sophisticated concepts, creating positive feedback loops that accelerate intellectual development. Ancient educational systems and knowledge transmission methods often demonstrate sophistication that exceeds what conventional models of cultural development predict. The guru-disciple traditions of ancient India, the mystery schools of Egypt and Greece, and similar knowledge preservation institutions worldwide develop techniques for transmitting complex technical knowledge across generations with minimal degradation. These systems suggest institutional structures designed specifically for preserving advanced knowledge. The timing of major technological transitions in human history correlates with astronomical events and cycles that might have significance for temporal manipulation technologies. The development of agriculture, the emergence of urban civilizations, and the appearance of written language all occur during periods that correspond to specific astronomical configurations. If temporal visitors used cosmic phenomena for navigation or timing, these correlations might reflect the scheduling of intervention events. The concept of temporal archaeology, studying the past for evidence of time travel interventions, requires new methodological approaches that combine traditional archaeological techniques with theoretical physics and information theory. Rather than assuming that all ancient achievements represent independent human development, temporal archaeology examines patterns of knowledge appearance, preservation, and transmission for signatures of systematic intervention. Quantum mechanics provides additional frameworks for understanding how temporal interventions might occur without violating causality. The concept of quantum entanglement, where particles maintain instantaneous correlations across arbitrary distances, suggests that information might be transmitted across time as well as space. Advanced civilizations might develop techniques for creating quantum correlations between past and future events, enabling information transfer that bypasses classical space-time limitations. The observer effect in quantum mechanics, where the act of observation affects the behavior of quantum systems, might provide mechanisms for temporal intervention that don't require physical travel to the past. By observing quantum systems in the present that were entangled with systems in the past, future civilizations might influence historical events through quantum mechanical correlations rather than direct physical intervention. Recent developments in quantum information theory suggest that information itself might be more fundamental than matter and energy. If consciousness and knowledge can be encoded in quantum information patterns, temporal displacement might involve transferring information patterns rather than physical objects. This would explain how advanced knowledge could appear in ancient texts without requiring the physical presence of time travelers. The concept of morphic resonance, proposed by biologist Rupert Sheldrake, suggests that patterns of organization and behavior can be transmitted across space and time through non-physical means. While controversial within mainstream science, this concept provides a potential mechanism for how knowledge and technological capabilities might propagate across temporal boundaries without requiring classical time travel. Archaeological evidence of precision manufacturing and advanced engineering techniques suggests access to knowledge that requires systematic experimental development. The creation of optical lenses in ancient times, the development of advanced metallurgical techniques, and the construction of precisely aligned astronomical monuments all demonstrate capabilities that typically require extended periods of research and development to achieve independently. The sudden appearance of these capabilities in the archaeological record, without clear developmental pathways, suggests knowledge transfer from more advanced sources. If this knowledge came from temporal visitors, it would explain both the sophistication of ancient achievements and the absence of expected developmental histories. The knowledge would appear suddenly because it was developed during different time periods and transferred backward rather than developed gradually within ancient civilizations. As we examine the totality of evidence, from the mathematical sophistication of ancient texts to the precision of megalithic constructions, from the advanced astronomical knowledge of early civilizations to the complex medical procedures described in ancient documents, patterns emerge that challenge conventional understanding of human intellectual development. The hypothesis of temporal intervention by advanced human civilizations provides a framework that explains these patterns more comprehensively than theories relying solely on independent ancient innovation. The implications extend far beyond historical curiosity. If our future descendants are already influencing our past, we might be living within a temporal ecosystem where past, present, and future exist in dynamic relationship. Our technological choices today might be influenced by knowledge of their future consequences, creating feedback loops that guide human development along optimal pathways. The question becomes not whether we have free will, but whether our free will operates within frameworks established by our own future wisdom. The evidence suggests that humanity's greatest achievements might represent collaborations across time itself, partnerships between ancient civilizations and their technologically advanced descendants, working together to ensure the survival and development of human consciousness across cosmic timescales. In this view, the ancient astronauts weren't visitors from distant stars, but emissaries from our own future, ensuring that the chain of causality leading to their existence remains unbroken across the vast cycles of cosmic time. Whether these interventions represent historical fact or compelling speculation, they demonstrate the power of human imagination to conceive possibilities that transcend the apparent limitations of linear time. As we continue developing technologies that manipulate space, time, and information, we might discover that our ancient ancestors documented not mythological fantasies, but actual memories of their descendants' temporal return. A cosmic inheritance that connects humanity's deepest past with its most distant future through the elegant mathematics of curved spacetime and the persistent power of human knowledge to transcend the boundaries of any single moment in time.